Thank you for coming back at our channel, The Physics Mindset. Now, engineers, electricians, and technical students, I need you in this topic. Today we are going to study about the transmission of voltage levels. You know, voltage from the generation, so that the moment it reaches your home, there is some levels of voltages which it passes through. And today's topic is transmission of voltage levels. Now you need to know these levels of voltages, from the transmission voltages to the voltage you use at home. Okay, now let me ask you something. Have you ever wondered why this generated electricity, which is in some small thousands, is transmitted in hundred thousands? Now check, why is it not that these electrical companies don't transmit? Transmission is using the poles, transferring electricity from one place to another. That is the transmission. Now, why these electricity companies don't transmit 400 volts or 500 volts? Why? Why do they need to step up this voltage? What is the reason behind stepping up the voltages? And that is what we are going to look at today. We're going to see the voltage levels, which transmission company is possible to transmit from one place to another. So from generation, we generate some thousands of voltages. Now, when it reaches in transmission, we again increase the step up from thousands to 100,000 of voltages when you are going to transmit. And we are going to see the reason why they do this in transmission. When they are transmitting electricity, why we use high voltages. There is a very crucial reason, and every electrician, every engineer, every technician need to know about this. Why we use high voltage. Okay, the knowledge behind, wait, and you're going to see the logic behind transmitting power in high voltages. Now let us dig into our topic today of transmission voltage levels. Now we are saying electricity is usually generated at around 11 kV. 11 kV, we are meaning 11,000. K stands for thousands. 11,000 volts to 25 kV, 25,000 volts. Okay, this is the generation. Electricity is usually generated at 11 kV. Not this. There is some science which you are going to look, which you are going to find out in this generation of 11 kV to 25 kV volts. Check the logic behind. Now, if we generate 11 kV or 25 kV in a power station or hydroelectric power station or generating station. Now, this is the station. They have generated 11 kV or 25 kV. Okay, this is the power station. Let us say hydroelectric power station. Okay, now help. Now this voltage is not the voltage they transmit. We are on transmission. This is not the voltage they transmit. This voltage, why they don't transmit this voltage? And once you hear it, 11 kV is 11,000 volts. 25 kV is 25,000 volts. Now, this is too much voltage, which is okay. This is high voltage, but we need to step up this voltage. Step it up by using a step-up transformer. As I told you, we have two types of transformers, the step up and the step down. Now this time round, on the generation of power, they generate 11 kV, 11,000 volts. Now we need to step up this voltage so that we reach on the size where we are able to transmit this voltage for a long distance. Transmitting electricity, we have cables responsible for carrying this electricity. Now these cables, if this is the pole, okay, this is the pylon, okay. Now these cables, this is a cable. This cable, let us say it is a 3-phase, live 1, live 2, live 3. Now this cable has some resistance. As you know, technically there is resistance in the cable, that resistivity. Now to transmit this 11K or 25 which is generated from this generator, we need to first step it up, because there is resistance, and where there is resistance, there will be some power losses. We shall lose some electricity because of the resistance of the cable. Now, when you increase the voltage, remember I told you, when voltage is increased, current goes down. Automatic. That's the logic behind. When we increase the voltage, current will go down. Those are two things. Check this. Let's try to bring this, let us try to simplify this explanation in water system. When you want to transfer water from one place to another with high pressure, from one place to another, we use high pressure. Okay? That high pressure, it pushes water. Even though it is a hill, it will go once you put this high pressure. Now, this high pressure will push the water from the source to where you want it. If there is less pressure, meaning water will not reach to the destination where you feel you want it. Now, this pressure is the voltage in electricity. Putting now in electricity, the pressure is the voltage, and the one which the voltage is pushing is the current. As I told you, current is electrons. Electrons, pressure is the force which push electrons. Now, the voltage, pressure is the voltage which push electrons. Electrons is the current. Now, voltage will push current to move through these cables. And once you increase the voltage, current will be low, will go down. Okay? And once the current goes down, there will be less power to be lost in these cables, transmission lines. Okay? Now, because we want this electricity to reach, let us say, if it is the country, it is the dam, hydroelectric power dam is in the eastern part of the country, whichever country you are. Okay? Now, we want to transfer this power, this electricity, from eastern side of the country to the western side of the country. We need this power to be the same power without loss. What should we do? We increase the voltage by using a step-up transformer, and once the voltage is increased, current will lower. Current is the one which makes the cables heat. Once current is too much, the cable heat up because of that resistance. It is the current which fights through the resistance. But once the voltage is very high, very big, current will pass very, very fast. And current, once we increase the voltage, it is logical that increase the voltage, current will lower, and power will be less. That's why we use this formula of power is equals current squared resistance. Okay? Because current will double lower when we increase the voltage, and the power will be stable. We shall not lose power. Losing power, I mean we shall not lose that electricity which we need to use into our houses. Instead of losing it in the cables during the transmission by heat. What causes heat is current. But once you step up this voltage, current will lower and you will not have heat in the cables. Transmission heats, transmission line. Now, we need to step up this voltage by using a step-up transformer. How? Let us step it up. We step this voltage, let's say, let us step the voltages up. Now these are the figures. Stepping up, step-up transformer, voltage. These are the figures. This transformer is going to step up this 12K. Once the 12K come into the transformer, okay, now 11K volts has entered the transformer. This is a TX, stands for transformer. Now transformer will step up the voltage to 66 kilovolts. That is 66,000 volts. Now it is 11K volts. It has stepped up to 66K. You see the difference? This comes for shorter distance transmission. For shorter distance transmission, not longer distance. In the area distance, that is the short distance. They transmit, they step up, transformer steps up to 66 kV. Okay, then it also steps up. Another transformer can step this voltage, this 11 kV or 25 kV into 132 kilovolts. That is when regional transmission. That is the regional transmission. By the way, this transmission, it depends in the area. How far are you going to transmit this electricity? It depends now with the transformer you're going to use. The transformer which steps up for how many voltage? You want a transformer which steps up a 66 kV. A transformer which steps up it depends on the distance. Now you can't get a 66 kilovolt transformer step up to step up the voltage when it is a national transmission grid. It is different. National transmission grid, it is national, as you hear. Now, in a short distance, we have 66 kV. In a regional transmission, we have 132 kilovolts. These are different transformers, okay? But they are stepping up the voltage from 11K, which is generated from the generator. The generator produced 11K to 25 kilovolts at the generating plant. Now we get this 11K or 25 into the transformer to step it up. When we want to transmit from one place to another, transmit, I said, putting it to these pylons or to the poles, okay? Live 1, live 2, live 3. Okay, this is now the transformer is here. TX. Transformer this is the generator. The generator produces 11 kV. It sends to the transformer, step-up transformer. A step-up transformer will step up to 66 or 122 for regional transmission, or a transformer which steps up 220 kilovolts. These are 1000 volts. If we say 220,000 volts, okay, 220,000, it is in 100,000 for long distance transmission. When it is long distance, not really long, but long, not countrywide or in one position, they use 220 kilovolt long distance. Now if it comes in national transmission grid, now national transmission grid, it means we can transmit this electricity from one country to another. National. We are now dealing in national. Another country can use this kind of electricity. Now, we shall step it up from 400,000. It is like this, 400,000 volts. 400,000. This is national grid. You can transmit this power to another country. And the other country also can use. Okay? Now, to transmit this transformer, after transmitting 400,000 kV, it will take it to these pylons to transmit. That's why you see these pylons. They pass through areas where people don't live. Okay? In the forest, you will find them. They pass there because they have a stronger magnetic fields which can affect human beings if you're living near it. So it is advised not to live near these pylons because of its magnetic field, which can affect even your brain, your health status. Okay? Now, after stepping up, these are, I'm telling you, the transmission voltage levels. The first level was, the generated level is 11 kV. The second level, let us say our regional, we are going to handle, let us say we are going to use 400 kV, or we use 220 kV. Which type of transformer you want to use? It depends. Or 132 kV regional transmission, long distance. It depends. National transmission grid. Okay, now we are going to step this voltage so that now it is on the transmission line, 400 kV. Now power is going. Now another level, it's going to substation. These are the levels of the voltage levels. After transmitting in high voltage, what we said in high voltage, that when the voltage is high, current will come down. And once the current comes down, it means we have less power loss in these cables. Power will be low because voltage is pushing at a high rate, and once the voltage is big, current goes down. Now, after this high voltage is being transmitted, we shall have a substation in the area. In your village or in your district, you have a substation where this power, this high voltage, reach before it reaches your house. Now, this substation, they use a type of transformer which is a step-down transformer. From a step up to a step-down transformer, to step down these high voltages which is being stepped up for the use of the transmission purpose. Remember, we generated 11K or 25K. It depends which type of generator. Okay, now we had to step it up. After stepping up, we transmit it in high voltages so that we don't lose this power. Which power is in the loss is in the current. Once the current is lowered, power loss decreases. And once current is high, power loss is very high because of the heating of the cable. That is the current. But once the current is down, it means when you step up the voltage, current will come down, and once the current comes down, power will be stable. You will not lose much power. By the way, if we don't step up this voltage, we shall have a lot of electricity loss. A lot of millions of money can be taken away by the power losses in the cables during the transmission. But once we step up the voltages, the power loss is decreased, and our power will reach in the substation with this power which we need. Now the substation in the area you are, this power will come to the substation. Now this is our substation, the transformer. It depends which transformer is going to be here to handle this 400 kV, 400 volts, 400,000 volts. The transformer will be able to hold this 400,000 volts. So this transformer, the step down, let us see the step down voltages. Once now the voltage, the 400 volt from the transmission line, it has reached your district, and once it has reached the district, it reaches at the substation. Which substation? We use a step down transformer. These are voltage levels which we are talking about today. A step down is going to step down, as you hear the name, step down transformer, step down the voltage from 400,000 to how many volts? It will step down to 11 kV. Again, it goes back, the logical goes back. A transformer can step down to 11 kV. It can step down to 25 kV. It can step down. Let us see the voltage levels for stepping down. Okay, now we are going to see the step. Once the transformer, now we are on the transformer stepping down. Okay, from transmitting, we selected 400,000 volts on the transmission line. Now it goes to the substation in your local village or the district. It has a substation where this high voltage reaches first. On the transformers, it has different type of transformers stepping down this high voltage. Okay, it is from east. Now we have it in the western side of the country in our substation. The other station, the hydroelectric power station, is the main power station. Now after generating from the transmission, now we have transmitted on the transmission lines with high voltages. Now it comes in the western side of the country in the one of the district, and it reaches the substation. It is a substation where we find the step down transformer. There in the main station we had a step up transformer, but here in the substation we have a step down transformer. Now a step down transformer will step down these voltages. Okay, check, we have a step down transformer voltages. Now it will step down. This is the transformer. So we have received 400 kV. It has come into our transformer. Okay, now this transformer is going to step down this 400 kV. Step it down. It will step down to 33 kV. Check the difference from 400,000 to 33,000. 433, you see the difference, meaning this one is being stepped down by that transformer. It is a primary for primary distribution. Okay, now again this step down transformer may step down this high voltage into 11 kV, 11,000 for local distributions. It steps down again when it reaches the substation. Then again the same step down transformer will step down the high voltage, the 4,000 volts, the 400,000 volts to 400 voltage or 415 volts. Okay, this transformer will step down to 400 or 415. That is where we call the name of the three-phase supply for industries. Industry now use this 400 volts, just volts, not 1,000. This is 400 k volts, but now it has stepped down to 400 just volts, 400 volts from 400,000. check this, from 400,000 to 400 only volts. This is 400,000, this is 400. Now this is what the factories use. Industries, factories, they use the 400 volts or 415 volts. That is the three-phase system. Commercial buildings, the buildings you see in the towns, in the cities, okay, those are buildings which use 400 or 415. They use this and they balance. One line can go this side, one phase can go this side, one phase can go this side, balancing the power. Okay, now again, that step down transformer, this step down transformer can step down to 230 or 240. It depends which country you are. Okay, 230 and 240 volts. For this is the single phase. Single phase, I mean, okay, let me go back small on the 400. When you say 400 or 415, that is three phase. Three phase mean they are, this is the pole, this is another pole. Okay, when it is three phase, it means there is a phase. A phase is the line, the power line. This is a phase one, then there is another line, phase 2, then there is another line, phase 3. This is where the name three phase comes in. This is a three-phase system. Now, even it may be with the neutral. This is phase 1, phase 2, phase 3, then the neutral. This is a three-phase, four-wire system. Now, which carries 415 volts. Step down. This transformer may step down to 415 volts. Three-phase system. Just know that is a three-phase system. Even the neutral. Now, if it comes to 230 to 240 volts, when they have stepped down the voltage, they have stepped down this voltage to 240 volts, this is a single phase. Which single phase is the one we use into our houses. You see how we are moving the journey of the transmission voltage levels? The levels of the voltages. From the generation to your house, to lighting your TVs, your lights, your charging your phones. From this 11 kV which it was generated to step up to 400,000 volts. Again, they stepped down to 240 volts for a single phase. Single phase, we mean this is the pole and this is the pole. Single phase, there is line 1, the poles you see overhead outside our houses. There is a cable, a wire which is having power, which is live, which I'll call it phase 1. Then there is another wire which is neutral. Now, meaning here, this transformer has stepped down to one cable which is carrying live, which is the phase. Phase the same as live. Another name to use live is phase. Okay? Phase 1 or live 1. Now, if we say single phase, it is just one. Single means one. Single phase or phase 1. Now this is a single phase for homes. We use this, which is 230 or 240 volts. Single phase system. Live and a neutral. That is single phase. Just know that is a single phase. When you see a neutral and a live, that is a single phase. If someone tells you, wire for me, use the single phase system, or you're going to wire for me a single phase system, just know you're going to use a live and a neutral. A neutral we don't normally count. We count them in the wire. This is a single phase. Technical term, when you're reading these transmission lines, we say a single phase, 2 wires. Even your house, you use single phase, 2 wires. because there is one wire is live, another wire is neutral. That's why we say a single phase two wire. This is live, neutral. This is a phase. Now it is single phase two wire. That's why your cables in the house, we use this single phase system. Okay, now I know we are getting stable in electricity, and we finished the generation, the fundamentals generation. Now we are on the transmission. We are looking on the we are talking about the transmission lines. We want to understand this transmission. What are the transmission? What are the step-up transformer? What are the step-down transformer? Where do you find the step-up transformer, and where do you find the step-down transformer? Okay, now without knowing this, you will not know. You will see people doing electrical poles, putting their wires, the phases, the overhead lines, and you don't know anything. But once you know the knowledge about it, it is very easy. You know what they are doing. If you find some people, if you're an electrician and you have done some electrical engineering courses, you can apply to the transmission companies. And once you have this knowledge with you, you know the voltages, high voltages. These are high voltages all. From generation, they generate 11K. After generating, again, they step up this generated voltage to 400,000 volts. Why? Why do they increase the voltage? To reduce on the power losses. We said on the power losses, once the voltage is high, current reduces. And once the current reduces, we shall not have heat in the cables. And once we don't have heat in the cables, it means we are not going to lose our electrical power. We shall transmit our electrical power because of this high pressure, high voltages. That's the logic behind why we use high voltages in transmission lines. And again, we step down this transmission voltage. You see, we first put it high when you're going to transmit it. Then if it reaches the area, we step it down again to these voltages. 33K, 11K, 400 volts, 415 volts, 3-phase, then 230, the one you use in the house, that is 240 or 230. It depends on which country you are. Some countries use 230, some countries use 240. It depends where you are. Okay, now once you know all these voltages and you are eager to move with us, and I know you are going to learn a lot of knowledge in electrical engineering. Now, you can't know these voltages without studying. There is no miracle which will come in your life. You need to study them, then you will understand the voltage levels, transmission voltage levels. You will know they generate how many volts, they transmit how many volts, they step up how many volts, again they step down to how many volts, so that it reaches into your house. Some people just see the electricity inside their house, but they know the levels, electrical levels, the voltage levels, which they have come. This, they step up, again they step down, again they step up, again they step down. Then it reaches into your house, into your home, to light your TV. But once they use this, your house will be on fire. 11K, that is too much, high voltage. They need to step it down. But remember, in transmission, again, this was very low. They had to step it to extremely high voltage. Extremely high voltage, 400,000 volts, 33,000 volts. You see, knowing electricity is a genuine thing everyone needs to have, because you need this knowledge in today's technology. The world is growing. You need the technology. There is no technology which doesn't use electricity. Electricity is applied in your day-to-day life every day. You use a phone. You need electricity to charge it. You need a charger. A charger needs electricity to power your phone, to charge your battery. The phone uses the battery. You will know that the battery is low. This is all knowledge on electricity. You will not know when the battery is low if you don't know something in electricity. But the moment you know something in electricity, everything comes. Technology comes very simple for you. And the moment we are going to enter into repair electronics, you will enjoy and you will see that these fundamentals of knowing electrical installations, electrical knowledge, is going to give you a very big fundamentals in solar systems and a very big fundamentals in electronic repair. You will not fail to repair anything. The moment you understand these things, the moment we start electronics, you will know much, and it will be very easy for you to repair anything, any technology, meaning technology will be in your hands, and it is your limit to stop repairing or to work on these technological equipments. Now, we are still working on the transmission. Don't miss the next video about the transmission. We are still talking about the transmission, and we shall after transmission we shall go to the distribution. That is where we are going to work on the cables, to know how to wire a house, to know how you connect a switch, you know how you connect a bulb, you know how you connect a cooker, you know how to connect a socket, everything. We are going to study them in the distribution. Distribution is now we are going to start wiring of the house. Pipe work, conduit work, slab work, all is in that part of the distribution, but we need to follow the steps. You can't understand distribution when you don't know transmission, and you can't understand the transmission when you don't know generation. Now, once you have the knowledge of generation, now we are having the knowledge of transmission. After the knowledge of transmission, we shall have the knowledge of distribution, and the knowledge of distribution is the best now. A lot of electricians are in that part, distribution, supplying power in people's houses, wiring. It's very interesting, but this is the mother. The mother is coming. We are soon finishing the mother. Then we start the real business of electrical wiring. You wire this, you connect live, and this, we are going to see everything. Connect live here and here, then switch, it will light. Okay? Thank you for watching today's video and the next video. See you there.